This is the P2 International A-Level October 2022 question 8. We've got a circle here, and we've got a cubic, and a tangent, and then we've got to work out this area here. So it mixes up a few different types of questions, so I thought I'd do this one. So there's a curve C1 is the cubic, it gives the equation. We've got to find the minimum turning point, which is T, and then we've got to find out where A is because it tells us the X coordinate. We find the equation of the circle, get the equation of the line, and then find this area. So there's C1. To find T, I need to put dy by dx, which is 3x squared minus 10x plus 3, and put that equal to 0 for a minimum point. Factorise, you can put it in your calculator, but I'm old fashioned, so I've factorised it, and we've got x is either a third from this one, which is going to be that maximum there, and so then the t is equal to 3, the x is equal to 3 at t. Want the coordinates though, is need the y value as well, so I put the 3 back into the original y expression, giving us 5, and they're the coordinates of t. Then we're going to find the equation of the circle. So we need the radius of the circle, which is AT. It tells us that the x coordinate is equal to 2, but I need the y value as well if I'm going to work out what the radius is. So stick that into the expression for the cubic, because A lies on the cubic as well. And that gives us 8, so the coordinates of A are 8. Then imagine drawing a right angle triangle here, and I want this radius. This is the difference in the y's, which is 8 minus 5. And then the difference in the x is 2 minus 3 or 3 minus 2. Do Pythagoras on them, and you get 10 for the, that's AT squared, of course. Don't bother doing the square root, because you want the radius squared for the equation of the circle. X minus the x value, y minus y value, both of those squared, gives you the radius squared. That's the equation of the circle. And then we want the equation of this L, this tangent. So I need the gradient. I've got a point that it goes through, but I need the gradient, the tangent. So I'll get the gradient of the radius, that AT, 8 minus 5 over 2 minus 3. That gives minus 3 for the gradient of the radius. Gradient of the tangent there, negative reciprocal, so it's a third. So I'll do y minus the y value at A is a third, x minus the x value. Multiply this bracket out, get a third of x minus 2/3, and add 8, you get 22/3 on the right hand side, which means the coordinates of the point where this line hits the y-axis is 22/3, which I'm going to need in a moment to find the exact value, exact area of R. Now, when I do the integration between 0 and 2, that's going to give me all of that area. And then I'm going to take away this area, the trapezium. So I'll do the integration, quarter x to the power of 4, 5/3 x cubed, 3 over 2x squared, and 14x. Putting 2 in, I don't bother with the 0 because it'll all be 0. That gives me 74/3. The area of the trapezium, well, I add the y values, divide by 2, then multiply by this, sort of the height of the trapezium, which actually still is width really, and it's just that top line because the 2's cancelled, and that gives you 46/3. And then to find the R, then just subtract them, 74/3, 2 over 4/3, give me 28/3.